Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. We are going to see the projections of points and the typical problems in it. If you want to learn this and many more interesting topics, please do subscribe the channel. And if you like this video, hit the like button. That will keep me motivated to do many such videos in the future. So coming to these projections of points, suppose we take a point A here, 40 mm above horizontal plane and 20 mm in front of VP. That means it is in the first quadrant. Okay. Let's imagine the planes here, and the point A is taken 40 mm above horizontal plane and 20 mm in front of vertical plane. This is 20. Now, this is a point called A, right? Drop perpendicular lines onto the planes here. This is a 20 mm line actually, right? This is 20 mm in front of VP. So this is 20 mm. Draw a projector, get the point here on the vertical plane, call it as A dash because it is the front view of A. So A dash. Now similarly, draw a perpendicular onto the horizontal plane, get the projection on the horizontal plane, right, at a distance of 40 mm. And this is called the top view of the point called A. That's why A is marked here. Draw projectors on this vertical and horizontal planes, right? This is parallel to this one, and this is parallel to this. Okay. Now we got the projections of point A here, A dash and A. But we have to represent this on a two-dimensional paper. So let's rotate this horizontal plane clockwise, right? Like this. This part is going upwards and this part going down. So both coincide here like this. And let's take the front view. This is at a height of 40 mm above the horizontal plane. So this is the reference line. From the reference line at a height of 40 mm, you get the front view, that is A dash. Okay. This is at a height of 40. Similarly, this point is top view is 20 mm in front of VP, but because we have turned the horizontal plane downwards, this point A comes here below the reference line. So at a height of 20 mm, mark this point, call it as A, draw a projector and mark the length. So 20 mm. These two are called the projections of this point called A. Now let's represent on a two-dimensional paper. Take XY line, a thin continuous line, right? Draw a perpendicular to this and mark 40 mm here. And at a point 40 mm height, you mark this point, that is called A dash. Show the distance, show the dimensioning, extend this line, and this is the top view of this point A. Okay, and draw a extension line and a dimension line. Show the dimension. So like this is the typical way of showing the projections of a point. When this point is in the first quadrant, we got these projections. That's why we call them as first angle projections. Okay, where the front view is above the reference line, top view is below the reference line. Now, let's take another point, say A, 15 mm above HP and 40 mm behind VP. That means it is in the second quadrant. So here it is 15 mm above HP and 40 mm behind VP, vertical plane. So we call this as A. This is the point A. Draw perpendicular lines onto the vertical plane and mark the projection here on the vertical plane. This is called A dash, right? This distance is 40 mm. Similarly, draw a perpendicular onto the horizontal plane and you get at a distance of 20 mm, 15 mm, you get the projection on the horizontal plane. This is called the top view. That's why it is indicated with the small letter A. Rotate this horizontal and also show the projectors here on the horizontal and vertical planes. Now, rotate this horizontal plane clockwise and you get a single plane like this coinciding horizontal plane with the vertical plane. Now, the front view is at a height of, from the reference line, it is at a height of 15 mm. So from the reference line, you mark a front view, that is A dash, at a distance of 15 mm, this distance, 15. Now, if you see the top view, that is A, it is at a distance of 40 mm from the reference line. Here it is, okay, at a distance of 40 mm. And because you are rotating the horizontal plane like this comes onto the top. So when you rotated, this top view also has come above the reference line, right? And this is called the A, top view. So this distance from here to here, this is 40 mm. Now, let's represent this same on the paper. Take the reference line, XY, draw perpendicular, right? At a distance of 40 mm, mark a point here, that is this distance. So 40 mm distance, mark this point, that is A. Next, at a height of 15 mm from here, at a height of 15 mm, we mark the front view, this A dash here. The distance is 15. So this is when the object is in the second quadrant. Now, another point A, 15 mm below HP, 65 mm behind VP. Let us see. It is in the third quadrant. So 15 mm below HP, this distance is 50, and this is 65 behind VP. That's why point is here. So 65, this distance. Draw the projectors, 65, and here the front view, it is below the reference line. Okay. Now 50 mm distance here from VP, from HP, mark 50 here. This is the top view of the point A. So mark small letter A, draw projectors on the horizontal and vertical planes. Now let's rotate and rotate the horizontal plane. Both the planes are coinciding. And if you get the front view here, right, it is below the reference line on the VP, of course, below the reference line. And the top view is here behind. Because you are rotating the horizontal plane like this comes on the top, right, above the reference line. So this point A, the top view is above the reference line. Now the front view is marked at 50 mm below the reference line. Top view marked at 65 mm above the reference line. Represent this on a two-dimensional paper. X, Y, right? Below, this is 50 mm, that is A dash. So here 50 mm, and this is 65 mm from the reference line only, 65 mm, and it is the top view. Okay, so here if you see, the point A is front view is below, top view is above. In the earlier case, when the point is in the first quadrant, we get the front view above the reference line here and the top view below the reference line. That means these two are interchanged, right? When the point is in the first and third quadrants. So the projections obtained here when the object is in the third quadrant are called third angle projections. But nowadays, universally, we are all following the first angle projections only. Okay, now take another point. So 40 mm below HP, this is 40, 25 in front of VP. So this is in fourth quadrant. Draw projectors again as it is, right? You get the front view and top view. Draw our projectors. Mark these distances here. Now let's rotate and rotate the horizontal plane. Got it? The top view, front view is below the reference line, right? When you are looking at it, this is the front view below the reference line. Top view is here on the horizontal plane, but rotating this also goes down. So A dash is at a distance of 40 mm. This is 40, and from here to here, this is 25. So represent this on a two-dimensional paper. Take 40 mm distance, mark it as A dash. Okay, this is the projection in the front view. At 25 mm distance from here, mark another point, right? That is the top view. So here it is 25 mm. So this is when the object is in the fourth quadrant. If you observe the object when it is in the second quadrant or fourth quadrant, both the projections, A dash as well as A, both the projections are on one side of the reference line only. When it is in the second quadrant, both are above. When they are in the fourth quadrant like this, both the projections are below the reference line. That is the difference. And one more thing, we don't have any such second angle projections or fourth angle projections, because if you are getting both the projections on one side. Suppose if my object is a complicated object and I got a top view here, and front view is also falling on this, it's very difficult to get the details. So there is no such second angle projection or fourth angle projection. Now, so far we have seen the problems with these planes. Now let's do them without all these planes by just understanding the position of the problem. So point A is in HP and 40 mm in front of VP. So in HP, that means when you are looking at it in the front view, the point is obtained on the reference line. Call it as A dash. In front of VP, that means the top view comes below the reference line, right? Because you are rotating the horizontal plane clockwise. So the top view obtained here below the reference line at a distance of 40 mm. So here it is the point A, top view. Mark the dimensioning here. That's it. So these are the projections of the point called A. Now take another point, 50 mm above HP and is in VP, right? When it is in VP, when you see it in the top view, the projection is obtained on the reference line like this. Call it as A, the top view. Now above HP, the point is above HP. That means front view is above the reference line. Draw a projector here perpendicular to this at A and mark 50 mm here above the reference line like this. That is called the front view, A dash. Take another point. A is in both HP as well as VP. That means point A is on the reference line. So just to take a point here, it is on the vertical plane as well as on the horizontal plane. Mark the same point as A dash as well as A. Okay. So these are all the problems. Basically, you have to understand the projections of points. So this will help you to understand it. Hope you had understood this topic very well. If you have any queries or suggestions, please do comment and do subscribe the channel and get alerts. Thank you.